Alright, so welcome back to our class in Phase 101. So in today's class video, we'll be doing the calculation aspects of projectile motion. In our previous class, we laid the theoretical aspect where I derived some equations on projectile. So in today's class video, we are going to do the calculation part of projectile motion. Okay, so let's start with the very first. And note these questions, they are in the they are in the back of your textbook in projectile. Okay, so let's start with the very first question. A ball shot at an angle of 60 degrees to the ground strikes a building 23 meters away at a point 60 meters high. Find the magnitude and direction of the final velocity of the ball as it strikes the ground. Now in this question, what are they telling us to look for? They are telling us to look for what? To look for the final velocity. Yes, they are telling us to look for the magnitude of the final velocity as well as the direction of the final velocity. Now, like what I said in the previous class, I told you guys that the final velocity is different from the normal vertical velocity or the horizontal velocity. I told you guys that final velocity is equals to what? Final velocity is equals to the square root of the square of the vertical velocity plus what? The square of the horizontal velocity. Remember, this velocity, this is the final vertical velocity, while this is what? Is the final horizontal velocity. Okay, so these two, they are different from this. Now in this question, they are telling us to look for what? To look for what? To look for this velocity. Okay, so remember, I told you guys that final velocity is the velocity with which the projectile used to hit the ground. Yes, used to hit the ground or used to hit an object. Okay, so that's what they are telling us to look for, the final velocity. So we are going to use this formula to look for the final velocity. But before then, let's analyze the question. Okay, now let's start again. A ball shot at an angle of what? 60 degrees. Okay, let me see. Look at this ball here, 60 degrees. Okay, so a ball shot at an angle of 60 degrees to the ground strikes a building 23 meters away. Okay, let's say this is the building here. Let's say this is the building. Then distance from where distance from the ball to the building was 23 meters. Okay, so a ball shot at an angle of 60 degrees to the ground strikes a building 23 meters away at a point. Now, the building is what? 23 meters away from where? From where the ball was projected, right? Okay, let's say this is the ball. Okay, so strikes a building 23 meters away, 23 meters away at a point 60 meters high. So the ball strike the building at what point? 16 meters high. Okay, 16 meters high. I don't know if you understand. 16 meters high. Okay, now they are telling us to look for what? To look for the magnitude and the direction of the final velocity. Okay, now remember, I told you guys that final velocity is equal to what? The square root of the square of the final vertical velocity plus the square of the final horizontal velocity, right? Yes. Now, if you look at the parameters here, we cannot use this. We cannot just, if you look at what they give us, they didn't give us the vertical velocity or the horizontal velocity. So in this, we are going to look for it using these parameters they give us. Now remember, in the previous class, I derived some certain equations that we can use to solve questions all these questions. Okay, so let me give you guys the equations. Now I gave you guys some equations on the vertical motion. I also gave you guys equations on horizontal motion. Now these are the equations on vertical motion. Okay, V equals to U sine theta, then minus GT. Yes, then another one S. Okay, based on the fact that it's vertical, to be what? H equals to what? U sine theta, then C, then minus half GT square. Then another one, V square equals to U sine theta all square minus 2GH. So these are all the equations on that. Remember, I told you, if you just go and check out the previous class video, I'll put the link somewhere here So just go and check the previous video where I derive all these questions. Where I derive all these equations. Okay. So these are the equations. In that video, I told you guys that projectile motions there are two motion: vertical motion and horizontal motion. And these motions are independent. I derive the equations under vertical motion. I also derive the equation under horizontal motion. Okay. So these are the equations under vertical motion. Then what about under horizontal motion? Under horizontal motion, so now be what? V is equals to what? U cos theta. This is one of the equations. Another one, S equals to, in bracket open, U cos theta t. Then the last one, V square equals to what? Bracket open, U cos theta square. So these are the equations under horizontal motion, while these are the equations under what? Vertical motion. Now in the question, they are telling us to look for what? To look for the final velocity, but they didn't give us the final vertical velocity and the final horizontal velocity. So we are going to use these parameters and some of this equation to get the final vertical velocity and to get the final horizontal velocity before we can get the final velocity. Okay, so now let's use some of these parameters to let's use some of these parameters and the equation to look for the velocities. Okay, so let's start now. Now if you look at it, this is what? This is horizontal distance, right? This is horizontal distance. Why this is what? This is vertical distance, or we can say this is height, right? So we are going to use this horizontal distance. We are going to use this horizontal distance to look for the vertical velocity. Then we are going to use this vertical distance, rather the height, to look for what? To look for the vertical velocity. Okay, we are going to use this horizontal distance to look for horizontal velocity, while we are going to use this vertical distance or height to look for the vertical velocity. Okay, so let's start. Now let's use this one. Remember, this S is the horizontal distance, right? So our S is what? 23. Okay, so 23 then equals to, bracket open. Now in the question, they didn't give us what? They didn't give us initial velocity. They didn't give us. Remember, I told you guys that this initial velocity, they are the same. This U, they are all the what? The initial velocity. Okay. So just go to the previous class video. You will see what I told you guys there. Okay. So now in the question, they didn't give us U. So we are going to, in the process of getting these guys, we are going to look for U first. Okay. Now let's continue. U, then cos what? Cos 60. Cos 60, bracket close, then t. They didn't give us time as well, so we will still look for time. Okay, then let's go to this other side on the vertical aspect. Our height is what? 16, right? So 16 bracket equals to, bracket open, and u, we don't know u, sine what? Sine 60, then bracket close, t, then minus what? Half gt square. Okay, so remember, g is what? 9.8. Okay, you guys know why the equation is negative. I've already explained it then. Okay, so let's continue. Now cos 60 is something as what? 0.5, right? So 23 is equals to what? Bracket open, u, everything here was 0.5, right? 0.5 is still the same as what? Half. So now be what? U half. Okay, u half, then bracket open, bracket close, t. So u times 1 will still give us what? Will still give us u. So everything here will now be what? I'm coming. Everything here will now be u over 2, right? Bracket close, then multiplying what? T, right? Then what about this side? 16 is equals to what? Bracket open. Now sine 60 is what? 0.866, right? So now be what? U, or let me say, okay, 0.866 u, bracket close, then we'll put t, right? Then minus, now g is what? 9.8. So half times 9.8 will give us 4.9. So 4.9 t square. Okay, we don't know t. So we don't know t, right? So let's continue. Okay, so let's continue. So I can clean this part now. I've already analyzed what we are going to do. So let me clean this part to save up space. Okay, all right. So let's continue. Okay, so we have arrived at this part. We have also arrived at this part. So what are we going to do next? Now, if you look at this part, we have two unknown. We have two unknown here, u and t, right? So let's just do something like this. Okay. So let's cross multiply. 2 times 23 will give us 46, right? To give us 46. So it's equals to what? Ut, right? So let's make u stand alone. U will now be what? 46 over t, right? Yes. Now wherever we see u in our u now is now equals to what? 46 over t, right? So wherever we see u, we'll place what? We'll place 46 over t. Okay. So wherever we see u here, we'll put what? 46 over what? 46 over t. So let's go to this part. So now 16 equals to what? Bracket open 0.866. Now u is what? U is what? 46 over t, right? So now be what? Times 46 over what? Over t. Bracket close, then our normal t, then minus what? 4.9 t square, right? Yes. We are not going to forget about this, okay? This side, we are not going to forget about it, okay? Now let's continue now. This time we cancel time, right? So 0.866 times 46 will give us what? 0.866 times 46 will give us 39 points. Let me just write it. So 16 is equals to what? If you multiply everything, here will be what? 39.836. Okay, then minus 4.9t square. Okay, so let's continue. If this one come over here, so now be what? So now be, okay, this one come over here, so now be 16 minus 39.836. Okay, so we'll now have what? Minus. Now if this one come over here, so now be minus. I told you guys, let's say, okay, 16 minus 39.836, then equals to minus 4.90 square, right? So if you minus everything here, we'll get what? We have minus 23.836 equals to what? Minus 4.9 t square. Okay, so this minus, you cancel this minus, right? Then divide both sides by 4.9. So let's divide both sides by 4.9. Okay, so dividing both sides by 4.9, I'm coming 836, then going to 4.9. Okay, 4.9 will cancel 4.9 here. So if this one divided, we get what? We have 4.864. So now I'm left with t squared is equals to what? 4.864. Okay. Now we're not looking for t square, we're looking for t. So we take the square root of both sides. Square root of both sides. This square will cancel this square. The square root of, let's look at the square root of 4.864. Okay, so square root of 4.864 give us 2.2. So our time is now what? It's now 2.2, right? So what do we do recently? Based on the fact that we have 23 equals to u over 2 then t, we use u to look for what? We use u to look for what? T. So we have gotten our t. Our time is what? 2.2, right? So now let's go back to this part. Since our time is 2.2, so 46 is going to 2.2. 46 is going to 2.2. To give us what? To give us 20.9. So the initial velocity is what? Is 20.9. Okay. So we have got our initial velocity was to be 20.9. Now let's impute. Okay. Now let's impute this 20.9 in. Let me show you guys the equation. Those are previous equations that I gave you guys. Okay. So let's impute this 20.9 wherever we see u. Okay, remember under horizontal velocity, under horizontal equation, we have equation like v equals to what? V equals to u cos theta, right? We have s equals to u cos theta, then t. Then we also have v squared equals to what? U cos theta all square, right? Yes. Then what about for vertical? Under vertical, we have v is equals to what? U sin theta minus gt. We also have h equals to bracket open u sin theta, then t, then minus 2gh. yes, no, half gt square rather, half gt square. Then last one, v square is equal to bracket open, use sine theta all square minus what, 2gh. Okay, so these velocities here, they are what? They are Vx. They are Vx. Why this velocity here, they are what? They have Vy. So we have used time to look for what? To look for our initial velocity. Okay. Now we can impute this initial velocity here, anywhere here, to get what? Our horizontal velocity and our what? Our vertical velocity. We can use any of these two here. Can also use any of these two here. Okay, so let's look for our horizontal velocity. Once we get our horizontal velocity and our vertical velocity, we put them here and we get our final velocity. So it's a long process. So let's continue. Now let's use this one. Let's look for our horizontal velocity. Remember, u is what? 20.9, right? So let's continue. Let's continue. So now be Vs is equals to what? U is what? 20.9. 20.9. And the angle is what? 60, right? So cos 60. So let's do it. 20.9 cos 60. 20.9 cos 60 will give us 10.45. So our horizontal, our velocity here is what? Is 10.45, right? Yes, so our velocity is what? 10.45. Let me check again. 20.9 cos 60. Okay, so yes, 10.45. Now worry about our vertical velocity. So we can use any of this one. So let's just use this one. So Vy will be what? Vy will be equals to what? U is what? U is 20.9, right? So 20.9 sin 60. Sin 60 is what? Sin 60 is 0.866, right? So times 0.866, then minus what? 9.8, then times, time is what? Time is 2.2, right? Yeah, our time is 2.2. Okay, so if we do everything, let's solve let's multiply everything. 20.9 then times 0.866. Okay, then minus 9.8 times 2.2. Okay, if we do everything, we have let me do it again. Let me do it separately. Okay, so 20.9 sin okay, 20.9 times 0.866. Okay, if we do it, we have, okay, 18.0994, then minus, okay, minus 9.8 times 2.2. Okay, 9.8 times 2.2. Okay, to give us 21.56. Okay, I'm coming. 21.56. So let's subtract it. So 18.0994, then minus 21.56. So if we do it, we will get what? We have our Vy to be what? To be minus 3.4606. Okay, so we have gotten our x, then we have gotten our y. So what are we going to do next? We are going to impute each of them in this place. Okay, so let's do it in this place. Okay, let's do it in this part here. Okay, so let's do it in this part here. So our v is what? V will now be equal to root. Vy is minus 3.4606. Then plus what? Vs is what? Bracket open, 10.45 all square. Now the square of a negative number will give us what? Will give us a positive number, right? So the square of minus 3.4606 bracket close all square will give us what? Will give us 11. Give us, I'm coming to give us 11.9757. Okay, 5 is a very long number. 236. Then plus the square of 10.45. The square of 10.45. Okay, the square of 10.45 will give us 109.2025. Okay, so let's add them. If we add them, let's add them. Okay, so 11.97575, then 236, then plus 109.2025. So if we add everything, we have what? We have and 121.1782524. So let's take the square root of this value. Let's take the square root of this value. So the square root of what? 121.1782524. Okay, so if we take the square root of everything here, if we take the square root of everything here, we'll get what? We have 11. Okay, we have 11.8 or so. So our velocity, the final velocity is what? Let's just leave it as what? 11 meters per second. So this is our final velocity. Our final velocity is what? Is 11 meters per second. Okay, yes. Now this is the this is the magnitude of the final velocity. Okay, this is the final velocity. Now they also tell us to look for what? To look for the direction of the final velocity. Now how are we going to look for the direction of the final velocity? I told you guys in the previous class video as well. So how are you going to look for the direction of the final velocity? The final velocity is equals to, look for the direction. Direction is equals to what? Tan theta equals to Vy over what? Vs, right? Yes. Now if you to make theta stand alone, you take the inverse of tan, right? So which is equals to what? Shift tan Vy over what? Vx, right? So let's continue. Our Vy is what? Our Vy is 3.4606. So 3.4606. Then divide by our Vx is what? 10.45. So let's divide them, okay? So let's divide them. 3.4606. I'm coming. 3.4606. Then divide 10.45. Okay, so when we divide them, we got what? I'm coming. Theta is equals to shift 0.33115784947. So let's take the shift tan of let's take the inverse tan of this value. So let's take a shift tan 0.3311578578947. Okay, so bracket close. So if we look at everything, our angle is what? Our angle is 18.3226 blah blah blah. So this is the angle, okay? Why this so this is the angle. So this is the direction of the final velocity. Why this is the magnitude of the final velocity. So in the first question, which is very long, you need there. So let's continue. The velocity is what? Velocity is 11 meters per second. Why the direction of the velocity is what? The magnitude of the velocity is what? Is 11 meters per second. Then the direction of the velocity is what? 18.3226. Okay, so yes, so that is how to solve that very first question. Okay, so please, I will advise you to go to the previous class video so that you can know how I derive those equations and how you can use them. Okay, so let's continue to with the next. Let's continue with the next question. Okay, coming. All right. So, oh my God, Crumbs is safe. I'm coming. A boy throws himself from, I think, the top. Okay, the top. Okay. Now for question two. A boy throws himself from the top of a diving board. So let me just illustrate it. Okay, let's say this is a diving board and let's say this is a boy. Okay, let's say this is a boy. Okay, so a boy throws himself from the top of a diving board with a horizontal velocity of what? 4 meters per second. So he throws himself with what? With an horizontal velocity of what? 4 meters per second. Remember, they said horizontal velocity. Okay, horizontal velocity. Okay, let's continue. Horizontal velocity of what? 4 meters per second, right? If he lands in the pool, let's say this is the pool. Let's say this is the pool. If he lands in the pool, 3 meters from, okay, I'm coming. Let's say okay. So if you land in the pool 3 meters from the point vertically below his point of projection. So let's say this is the pool. It land in the pool 3, which is 3 meter away from what? From the point vertically below, from the point vertically below his point of projection. Okay, so from this part to here is what? 3 meter. Okay, so okay, let's continue. Below his point of projection, how high is the diving board? So they're telling us to look for what? To look for the height of what? The diving board. Okay, so it's very easy. So a boy throws himself into a pool, which is what? 3 meter away from what? From this point here. Okay, from vertically below his point of projection. Okay, so a boy throws himself into a pool with a speed of what? With an horizontal velocity rather of 4 meter per second into a pool, and the pool is what? 3 meter away. Okay, now they're telling us to calculate for what? The height of what? Of okay, how high is the diving board? So they are telling us to look for what? The height of the diving board. Okay, now this question is still easy. Okay, so I will advise you to go to the previous class video. Very important. Go to that video because that is where they have equations, and I told you guys how the scenarios in which you can use some of the equations. Okay, so now if you look at it, look at this. This, remember in that previous class, I told you guys that range is what? Horizontal distance, right? From the point of projection. Okay, so this 3 meter is what? Is the range. I don't know if you understand. This 3 meter is the range. Then this velocity what? Is what? Horizontal velocity. Now what is range? I gave you guys the formula then. Range is equal to what? VT, right? Yes. That is UT rather. UT. Okay. Yes. And this U is what? Is horizontal velocity. Yes, I gave you guys in our previous class video. Okay, so range equals to velocity times what? Times time, right? And this velocity is what? Horizontal velocity. While range is what? Horizontal or distance, right? Yes. Now, this is the range. This is range. If you look in this question, they are telling us to look for what? To look for height. Now, what is the form? Well, which formula are we going to use to calculate for height normally? The formula we're going to use is what? H under remember, height is related to vertical equation. Remember, projectile is has two motion, horizontal motion and vertical motion. I gave you guys equation under horizontal. I also gave you guys equation under vertical. Now under vertical, we have V. Okay, I gave you guys then V equals to U sin theta minus GT. H equals to U sin theta, then T minus half GT square. Then V square equals to bracket open U sin theta square then minus 2GH, right? Yes. Now, these are the vertical equations. Range is related to horizontal, okay? Now, in this question, tell us to look for what? The height, right? So we are going to use this one, okay? Now, but if you look at it, there is no angle. In the question, there is no angle, so we are going to neglect the angle. We are using this second equation, so we are going to neglect what? The angle. So we now have something like this. H is equals to what? UT minus what? Half GT square. I mean, if you understand. So we have something like this, okay? We are using the second vertical equation motion. Vertical equation. Yeah, vertical equation. Okay. So which is this, okay? We are looking for what? The height, right? Yes. Now, since we are looking for the height, we all know G. G is on 4.9. Yes, we all know G. Then this one is what? U is initial velocity. But they didn't give us initial velocity in this question. So initial velocity was 0. Okay. Horizontal velocity is different from initial velocity. So U is 0. Then U, I explained it. US is different from U. I've explained it, okay, in the previous class. So let's continue. So U is there's in the question, they didn't give us initial velocity. They only tell us that he died with the horizontal velocity. So horizontal velocity is different from initial velocity. Okay, horizontal velocity is equals to what? The initial velocity itself, then cos theta, right? So yes. So let's continue. Okay, so let's continue. U is 0, then G is what? 4.9.8. Okay, but in the question they didn't give us time. I don't know if you understand. In the question they didn't give us time. So how are we going to do it? We are going to use this one to look for the time. Once we get our time, we put it here and we get our height. Okay, so let's use this ones to look to get time. Now range is what? Our range is what? 3, right? 3 is equals to what? The initial velocity is what? The horizontal velocity is what? Is 4. So range equals to 4, then T. So making this time would now be what? 3 going to what? 4. So our time will now be what? 3 going to 3 divided 4. 3 divided 4 will give us 0.75. So the time is what? The time is what? 0.75. Okay, now we're going to impute this time now in this place. Okay, so let's continue. Now A should not be equals to what? Remember, U is 0, right? Then they give us initial velocity. So 0 times T will give us 0. Now be left with what? This part. So now be half times what? Half times now be half times 9.8. Half times 9.8 will give us minus 4.9, right? Because you have minus here, then times time is what? 0.75. So times the square of 0.75. Okay, the square of 0.75. Okay, so let's do it. 4.9 then times the square of 0.75. Okay, so when we do it, we have what? 2.75. Okay, so our height is what? Our height is what? 2.75 meter. 2.75 meter. So this is our answer. Okay, so this is our answer. 2.75 meters. So that is the second question. Okay, so the height of the David board is what? Is 2.75 meter. Okay, so let's move to the third question. Okay, so let's move to the third question. So let's continue with the next question, which is question 3. A particle, or rather particle, is fired from the top of a cliff of 49-meter high. Okay, so let me just draw the cliff here. Okay, so let's say this is the cliff, for example. So a particle is fired from the top of a cliff of 49-meter high. So the height of the cliff is what? Is 49 meter. Okay, so the height of the cliff is 49 meter. Particle is fired from the top of a cliff of 49 meter with a speed of 40 meter per second at an angle 45 degree to the horizontal. Okay, so let's say the particle is fired from the top of a cliff of 49 meter high with a speed of what? Let's say this is the speed, 40 meter per second at an angle of what? 45 degree. An angle of 45 degree to the horizontal. Okay, so this is the angle, then this is the speed with which the particle was fired. Okay, now why this one is the height of what? Of the cliff. Okay, a particle is fired from the top of a cliff of what? 49 meter high. Let me write it well. 49 meter high with a speed of what? 40 meter per second at an angle of 45 degree to the what? To the horizontal. Now find the maximum height reached and the point where the particles enter the what? When the particle enter the sea. Okay, so let's say the particle finally enter the sea at this point. Okay, so what are they telling us to do? They are telling us to look for what? To look for what? To look for the maximum height first. Then also look for what? To look for the maximum height. Then they're also telling us that to look for what? The point where the particle enter the sea. Now that point where the particle enter the sea, from the point of projection, that point is known as what? Is known as the range. Okay, so they're asking us to look for two things. They're asking us to look for what? To look for the maximum height, as well as what? As well as the range. Okay, so what are we going to do next? Now remember I gave you guys equations under. Okay, I think I should clean this part. Okay, let me just clean this part so that I can solve. I'm coming. Okay, so let me manage space. All right, so remember I gave you guys equations under vertical. I gave you guys vertical equations. Yes, equations under vertical motion in projectile. I also give you guys equations under horizontal motion in projectile. Okay, so in the question they are asking us to look for what? To look for the maximum height and what? And also to look for what? To look for the range. Now if you watch the previous class video, in the end of that video I did something like this. In the end of the video I told you guys something that, for example, in some particular question that they will ask you to calculate for the total height from the ground. I did something like this when I told you guys that, oh, this one H is what? Is the height of the tower, or the height of I used tau in the previous video. So let's say they'll tell you to calculate for, let's say, the total height. So you guys that this one will be the height of the tower or the height of the cliff. While from here to this point will be what? Will be the height from the tower, from the top of the tower to what? To the maximum height. I told you guys. Then I also tell you guys that from the distance from height from here to here, and which is the total height, is the same as what? The total height rather is the same as what? From here to here. I don't know if you understand. Distance from here to here is the same as what? Distance from here to here. Okay, I told you guys that total height will be equal to what? H plus capital letter H, right? Yes. So we'll come across something like this in this place. Okay. So now I'm coming. So remember, I gave you guys equations under vertical motion, right? I also give you guys equations under horizontal motion. So the equations under horizontal motion are what? V equals to bracket open U cos theta, right? Yeah, this is under horizontal. Then S equals to bracket open U cos theta, bracket close, then T. Then the last one, V square is equals to bracket open U cos theta, bracket close, all square, right? While under the vertical, I give you guys that V is equals to what? Bracket open V equals to, okay, bracket open U sine theta, right? Or let me, okay, U sine theta, then minus GT, then another one, H equals to what? Bracket open U sine theta, bracket close, T, then minus half GT square, right? Then the last one, I said that V square is equals to what? Bracket open U sine theta, bracket close, all square, then minus what? 2GH, right? Yes. So these are the equations under the vertical motion, while in projectile, while these are the equations under horizontal motion in projectile. Now they're telling us to look for two things. Yes. They're telling us to look for the range as well as the maximum height. Okay? Yes. Now, do you think the maximum height in which they are telling us to look for? They're telling us to look for what? The height, which is the total height from this place, from the ground to this point here. I don't know if you understand. So from the ground to this point here. I don't know if you understand. So from here, okay, I'm coming. So from this, it's just like the scenario that I just drew recently, Nana. When I told you guys that something like this, that the total height will be what? The total height will be what? The height of the tower plus what? The height from the tower to the maximum height. Yes. So rather they are telling us to look for what? To look forward to the total height. Yes. From this place to this place, which is known as the total height, or what? Or you can say the maximum height. Okay. So that's what we are going to do. I don't know if you understand. We have already gotten our H. Okay. Yes. We have gotten our H. Then we need to look for what? Capital letter H. When we look for capital letter H, we add everything. We get what? We get our total height. Yes. Then what about range? Remember, range is what? Range is equals to what? Yeah, this question 2 is range. Yes, remember range is equals to what? UT, right? Yes, and I told you guys that U is what? In the previous class, I told you guys that U is what? U cos theta, right? T. I told you guys, yes. I told you guys that let me just range is equals to UX rather. UST. Then this US is what? US is equals to what? U cos theta, right? Then man times the T. So range is the same thing as what? This second equation, right? So they are telling us to look for the range. Yes, they are telling us to look for the range. After the guys how we can look for what? To look for the total height or the maximum height. I've told you guys already that we have already gotten this one. We are going to look for this, then this one, then we sum it, we have our total height. Then why for this one? Why for the range? We are going to use this formula. Now they gave us the initial velocity, which is 14. They gave us the angle, which is 45, but they didn't give us time. So how are we going to look for time? Because if we don't look for time, we cannot get the range. Okay, so we are going to use where can we get time? We can get time using this second equation. Okay, because where this second equation, this H is this one here, 46. I don't know if you understand. So we use this H. Then U remember U is what? U is 14, right? We use this H, U, then the angle, then to look for what? To look for T. Once we get T, we impute t to it to this place, get our range. I don't know if you understand. Okay, so let me recapitulate. Our total height, we use 49 plus what, our not plus the height we are going to calculate, sum it, we get our total height. One range, they have already give us the u, we know our angle, but the time we are going to use what, this formula or this equation to look for what, look for the time. Okay, so let's look for time first. So I can clear this place. I've already analyzed everything, right? So I can clean this place. Okay, so our age, normally our age is what, 49, right? So we have to look for what, we have to look for this capital letter H. But before then, okay, let's look for this capital letter H first. Okay, remember time of maximum. What is formula to look for maximum height? Formula to look for maximum height is what? Because we use square sine what, sine square theta, right? All over what, 2g, right? Yes, in the previous class I told you guys that one. So what is our velocity H? Now our velocity is what, is 14, right? So 14 all square, then sine what, sine what, 45, right? So sine, the angle is 45, so sine 45 all square divided what, 2 times what, 9.8. G is what, 9.8. So let's look at our H first. Okay, so let's do everything. Okay, I'm coming. Okay, so let's do it. Now 14 square, then times bracket open, sine 45 bracket close, all square, then divided by what, 2 times 9.8. So I'm coming. So let's do it again. I'm coming because it said math error. 14 square. Before then, let's just look for sine 45 is what, is sine 45 is 0.7071. So let's just do it like that. So sine 45 is what, 0. Let's convert it first. 0.7071. Okay, so let's do it again now. Okay, let's do it again. All right, 14 square, then times bracket open, 0.7071 bracket close, all square, then divide by what, 2 times 9.8. Okay, so yes, our this height here is what, 4.99, which is approximately what, 5. Okay, so let's add this now. Our capital letter H is what, 5 abi. So let's add it. 49 plus 5 will give us what, 49 plus 5 will give us 49 plus 5 will give us 54. So the total height is what, 54. Okay, 54 meter. 54 meter. Okay, so we have gotten our total height. Our total height is what, from year to year, our total height is what, is 54. Now what are we going to do next? Let's look for what, let's look for range. How are we going to look for range? We are going to use this second equation to look for time. Yes, we are going to use second equation to look for time. Remember, this is small letter H is what, is 49. So we are going to use small letter H and the rest to look for what, time. Okay, so let me clear this part. Okay, all right, I'm coming. Okay, all right, now let's use the second equation now to look for time first. So H, which is 49, right? 49 is equals to what? Bracket open. U is what? U is 14, right? Yes, U is 14. Then sine 45. The angle is 45. The bracket close, time. We are looking for time minus what? Half G. G is G is 9.8, right? Half times 9.8 will give us what? 4.9. So 4.9, then the t square, right? Yes. Okay, now sine 45 is something as well. It's 0.7071. Sine 45 is 0.7071. 0.7071 times 14 will give us what? 14 times 0.7071 will give us what? Will give us 9.8994. So everything here will now be what? Now be 9.8994. Okay, so now this, we have arrived in a particular equation, and this equation looks familiar. If you have watched our class video on mechanics, where we did something like this relating to quadratic equation, because this equation now is a quadratic equation. I don't know if you understand. So this equation is a quadratic equation. So what are we going to do? If you can go to our previous class, I think that is in mechanics. Yes, in mechanics, I told you guys how to use the almighty formula or quadratic formula to solve questions under quadratic equation. Okay, so this is quadratic equation. Okay, now remember, I will put a video link somewhere here so that you can go watch the video as well. So now let me continue. Now in quadratic equation, as square plus bs plus c is equals to 0, right? Yes. Now the one we call mathematical formula, or rather quadratic formula, which is an x is equals to what? Minus b plus minus bracket open b square minus 4ac bracket open what? 2a, right? So this formula, this one we call mathematical formula or quadratic equation, is gotten from what? Is gotten from this. Okay, yes. Now why am I bringing this out? Now I'm bringing this out so that we can identify which of these guys is a, which of these guys, because we are going to input each of them here. Okay, so I'm bringing this one out so that we can know which one is a, which one is b, which one is c. Okay, so remember in that previous class in mechanics I told you guys that a is the one that usually that has a variable that takes square. I don't even understand. A is one that usually have a variable that takes square. Now, which of this one has a variable that takes square? Is this one, right? So our A is what? A is let me clean this part now. B. Okay, let me clean this part. Okay. So our A is what? Minus 4.9, right? Yes. So A always carries variable that carries square. Don't worry about B. B only just carry a variable. The variable does not take square. Now, which of these carry a variable? Which of these carry a letter only? Is this one, right? T X T S. So this one will be B, right? Because if you look at this one, B, the X does not take square. This one, the T does not take square. So this one is what? B. Okay. So B is what? B is 9.89. Let me use 9.89. Okay. Okay, 9.8994. Anyone? Then our C definitely will be what? Our C will be what? Will be 49, right? So our C will be 49. Okay? Yes. So our C will be 49. C is one that does not take a variable. Okay, so C is 49. Now let's continue. Now let's impute. We are going to impute what? All these values inside this equation. Okay. So let me write the equation again. So now in the place of x, I'm coming x equals minus b plus minus root b square minus 4ac all over what? All over 2a, right? Yes. Now what are we doing, by the way? Wow, we were looking for t, right? We are looking for t. When we were solving for t, we arrive in this place. Yes. And we cannot just minus, because one of them is carrying square. Cannot just minus. You cannot minus a square from another number entirely. I don't understand. So it will be very hard. So that's why we are using quadratic equation, because this equation, because this equation here is a quadratic equation. Okay, so we are going to use quadratic equation to look for what? To look for the time. Now in the place of x, based on the fact that we are looking for time, we use what? We put t. Okay, we put t. So let's continue. Our b is what? B is, let's continue. So T will be equals to what? B is what? 9.89, 9.8994. Then plus, okay, remember there's minus. Don't forget to this minus. Okay, then root B again is 9.8994, right? All square, then minus 4. 4 times our A is what? A is minus 4.9, right? Well, okay, minus 4.9 minus 4.9. Then times C is what? 49. Okay. So then divide by what? Or divide by 2 times A is what? A is minus what? 4.9, right? So let's continue. Wow, it's not easy. So let's continue. So T will now be what? T will now be equals to minus 9.8994 plus minus 9. The square of 9.8994 will give us 97.99. So 97.99. Okay, then minus. Now, okay, let me remove the minus first. Minus 4 times minus 4.9 times 49. Remember, when a negative number multiply a negative number, it will become a positive number, right? So if we multiply all this, minus 4 times minus 4.9 times 49, to give us what? To give us a positive number, right? So let's do it. Minus 4 times minus 4 times minus 4 times minus 4.9 times 49. will give us what? 960. So plus what? 960.4, right? So okay. Then divide by what? Now 2 times minus 4.9 will give us minus 9.8, right? So let's add this one. If we add it, let's add the 97.99 plus 960.4. If we add it, we have okay, let me clean this part. So we have coming. Sorry. Okay, so we have okay, if we add everything here, let me just do it here. If we add these two, we have coming 1058.39. Okay, so 1058 point what 39. Okay, so we have to look for the square root. Take the square root of 1058.39. Square root of 1058.39. So when we take the square root, we got what? 32.53. So everything, let me clean itself. Okay, so if we take the square root, it will now be I'm coming 32.532. 32.532. Now there's let me just continue 90, then 642. Okay, so now remember here is what? Plus or minus, right? Plus or minus, right? Now while the under is what? The under is what? Minus 9.8, right? Yes. Okay, so we have arrived in something like this. Now remember, in quadratic equation, the answer is always 2, right? Yeah, we always have 2 answer. Okay, so now this plus or minus, so it tells us that one of the equation is positive and the other of the equation is negative. Okay, so we are going to split the equation into 2 because of what? Because of this plus and minus. Okay, so we are going to split all this into 2. Now let me do one part first. So our t, let me say t1 is equals to what? Minus 9.8994, then plus one of them is positive, the other one will be negative, so plus what? 3, I'm coming plus 32.53290, then 642, then divide by what? Divide by minus what? Minus 9.8, right? Then let me write the second equation. Let me use this part now. Let me write the second equation. Okay, so all right, so writing the second equation, T2 will be what? T2 will be equals to minus 9.8994. Then we'll not use what? We'll not use minus, right? Because the other one is plus, right? So minus 32.53290, then 642. All divided by 1 minus 9.8. Okay, so these are our T1, this is our T2. Now let's do this one first. Minus 9.8994, then plus 32.53290, then 642. So divide by, we get 22.633, blah blah. Now let's divide this with what? Minus 9.8. So divide by 1 minus 9.8. So when we divide everything, our answer is, our T1 is what? Is equals to minus 2.309, or we can say 2.31, approximately 2.31. Okay, so now let's do this part. Okay, let's do this part now. Minus 9. So our T1 is 1 minus 2.31, right? So let's do this part now. So minus 9.8994, then minus 32.53290,642. Okay, I'm coming. All right, so divided by what? Minus 9.8. So we get what? Our T2 is what? 4.32. So our T2 is what? 4.32 now, approximately what? 4.33 or seconds, right? So we got, I'm coming. So we got 2 times. T1 is minus 2.31 seconds. T2 is what? 4.33 seconds. So now remember, we are not going to use since we got to time, we are going to use 1. Now we are not going to use this other one, the one that has minus, because why? When time, because there's nothing like negative time. Minus 3.2 minus 2.31 seconds means that we are going backward. We are going back in time, which is impossible. Okay, so time does not take negative. When time take negative, it means that we are going back in time, and that is impossible. So we are going to use this first one. We are going to use the second one. Okay, so we have finally gotten what? We have finally gotten, my goodness, finally gotten our time. Okay, now what are we looking for? We are looking for range, right? Range equals to u cos theta, right? Remember, then times t. So we have finally gotten our time. Remember, don't forget to don't let the quadratic equation forget what we are looking for ever since. Remember, in the question originally, we are looking for what? We have gotten our height and we're looking for our range. And I told you guys that we need to get our time first. Once we get our time, we can use input it to get our range. Okay, so let's continue now. Since we have gotten our time to be 4.33, now our range, we are looking for range, right? So arrow will now be equals to what? U is what? U is 14, then cos what? 45, then times what? 4.33, right? So let's do everything. Now, cos 45 is 0.7071. Okay, so let me check it first. Cos 45, yes, 0.7071. So 14 times what? 0.7071. Okay, so let's multiply everything now. Now be 14 times 0.7071, then times what? 4.33. Okay, so when we do everything, get our range to be 42.86 meter. Okay, so this is our range. Okay, 42.86 meter. Then while our total height is what? 54 meter. Okay, so you can approximate, if you approximate now, to be 43 meter, or that, let's say if you approximate now, it can be 43 meter. We can also approximate, we get what? 42.9, which is same thing as what? 43. So in all cases, we are correct. Okay, so these are ones. So this is the range. This is the height. Okay, so let's continue with the remaining question. Okay, so these are the many questions: question 4, question 5, and question 6. Okay, so I will start with solving question 4, then I will solve question 6 before I move to question 5, because question 5 is quite long. Okay, so now let's start with question 4. What is the least velocity? What is the least velocity of projection required to obtain a horizontal range of 100 meter? And what will be the time of flight? Okay, so we are looking for two things here in this question. We are looking for what? The least velocity, or you can say the minimum velocity. Okay, we are looking for the least velocity, and we are also looking for what? The time of flight. Now the time of flight here, they are referring to the total time of flight. Okay, so we are looking for two things here. Okay, yes. Now in this question, they gave us what? They gave us range to be 100 meter, and they gave us g. Okay, so which equation, which formula are we going to use to solve for the velocity? We are going to use the formula of range. Okay, remember in the previous class video, I gave you guys about 4 or 3 formulas for range. One of them I gave you guys that r is equals to what? U(x), then times time. Another one, r equals to what? U squared sine what? Sine 2 theta over what? G, right? Yes. I also give you guys that range is maximum. When range is maximum, the formula is r equals to u square over what? U square all over what? G, right? Yes. So remember, this u(x), in the previous class I told you guys u(x) is equals to what? U cos theta, right? U cos theta, right? So imputing this into here to now be what? R equals to what? U cos theta t, right? Yes. So they are about this formula, this equations. We use this formula for when they give you an angle. Why we use this one? When range is maximum. Yes, when they tell us to solve for maximum range. Why we use this one or this? No, they are the same thing, right? Well, we use this one when they gave us angle, they gave us time as well. Yes. So in this question, they're asking us to look for what? They're asking us to look for the least, very important, least velocity. They also look for the least velocity and they're asking us to also look for what? The time of flight. They gave us range. We all know G is always 10 or 9.8, right? So which formula of range are we going to use to get velocity? Okay, so let's check this first one. Like these ones, these two, they are the same thing, right? So let's check this. We are not going to use this because why? Because they didn't give us time in the question. I don't know if you understand. So we are not going to use this one. We are eliminating them at. Okay. So now, what about this other one? This two, which one are we going to use? Are we going to use this or are we going to use this? Now, take notes. Very, very important. Very, very important. I didn't say it in the previous class video, sha. Let me just tell you guys now. Whenever you see least velocity, relating to range, least velocity relating to range, the least velocity of projection, they will not tell you least velocity of projection occurs when range is maximum. I don't know if you understand. Least velocity of projection of the body usually occur when the angle is what? 45 degree. Remember, when the angle is 40, range is maximum when the angle is what? When the angle is 45 degree. I don't know if you understand. That is why they placed least velocity here. They didn't tell that's why they placed least or minimum velocity or minimum. Because they didn't put angle in this question, right? They didn't put any angle. But they placed angle like there's angle, but they didn't put it directly. This least velocity, take note, range, least velocity of projection relating to range usually occur when the angle of projection is what? Usually 45 degree. And remember, at 45 degree, range is what? Range is maximum, while the velocity is what? Minimum. Okay, so take note. Okay, take note that the least velocity of projection usually occurs at what? At angle 45. Okay, so remember, since they're asking us to look for least velocity, since they're asking us to least velocity, this least velocity usually occur when what? When range is maximum. So we are going to use the second formula. Even though we use this first formula, we still get the same answer. I don't even understand. Okay, because where if we place this angle here, we will arrive back to this. Okay, so let me just show you. U square sine angle is 45, right? 45 times 2 times 45 will give us 90, right? So sin 90 is what? 1. Sin 90 is 1. So u square times 1 will still give us what? Will still give us u square. So it now be u square over our g. So we have arrived at this. Okay. So we are going to use that the same thing, all right? So range is when they say range is maximum. When range is maximum at 45 degrees. So we are going to use the second formula, right? Yes. So let's use the second formula. What are we looking for? We are looking for the least velocity. Least velocity occur when the angle is what? When the angle is what? 45 degree. And as that angle, range is maximum also at that angle. So let's continue. The range is what? The range is 100, right? So 100 then equals to what? U square. We are looking for u. Then divide by what? Divide 10, right? So if you cross multiply, u square will now be equals to what? U square will now be equals to 1000, right? So take the square root of 1000. The square root of 1000. The square root of 1000 is square root of 1000 is 31.62. So our velocity is what? Is 31.62 meter per seconds. Okay, so this is our what? This is our velocity. The least velocity is what? 31.62. Okay, yes. So what are we looking for next? We are looking for what? We have got our velocity to be 31.62. Now we are going to look for what? We are going to look for the time of flight. Okay, so how are we going to look at it? Remember, I told you guys that this time of flight that they tell us to look for is total time of flight. And what is total time of flight? Total time of flight is equal to what? 2u sine theta over what? G, right? Yes. Remember, I told you guys that since they placed least velocity, they are indirectly telling you that the angle here is what? 45 degree. I don't know if you understand. They are telling us that, oh, They will not tell, they didn't tell us directly. They just say least velocity. And least velocity of projection usually occur when what? Least velocity of projection usually occur when the angle is 45 degrees. Okay, so let's continue. So we're looking for time of flight, right? So t will be equals to what? 2 times our velocity is what? 31.62, right? Then times what? Now times the angle is 45, right? So sine 45. Sine 45 is 0.7071. 0.7071. Then divide by what? 10. Okay, so let's do it. Let's see. So 2 times 3, 31.62, then times 0.707071, then divide by 10. So our answer is 4.47. So the time is what? Is 4.47 seconds. Okay, so this is the time. Okay, so we are done with the fourth question. Now let's go to the sixth question. I will solve this one last. So let's go to the sixth question. Okay, this sixth question is not that long as well. Okay, so in the sixth question, during a football match, the ball kick at 45 degree angle of elevation. Okay, let's say this is the player. He kicked the ball. Let's say this is the ball at what? At angle 45 degree, right? So during a football match, the ball kicked at 45 degree angle of elevation went just over the goalpost. Let's say this is the ball traveling. So so let's say this is the goalpost. Okay, let's say this is the goalpost. Okay, so the kick at 45 degree angle of elevation went just over the goalpost, height 2.4 meter. So the height of the goalpost is what? 2.4 meter. Okay, so that is the part of the goalpost it went. Went just over the goalpost height 2.4 meter. Okay, so from the point in which it hits the goalpost, that height was 2.4. Assuming the goalpost height is the greatest height, calculate the speed of projection. Okay, so they are telling us to calculate for what? The speed of projection. I don't even understand. They gave us height. Went just over the goalpost. Height 2.4. Assuming the goalpost height is the greatest height, they are telling us that this height so is the greatest height, which is maximum height, right? So they are telling us to look for the speed of projection, as well as the time it takes to reach the greatest height, as well as the horizontal distance, which is range. So let's do it. So let's look for they're giving us the height already, which is maximum height. Now let's look at this velocity. Maximum height is what? It's equals to u square sine what? Sine square theta. Sine square theta over what? 2g, right? So let me clean this part. Okay, so let me be fast. I don't want this video to be long. So the velocity, we are looking for the velocity, right? Our height is what? Our height is 2.4. So 2.4 is equals to what? We are looking for velocity. So u square then sine square theta, right? Theta is what? 45. So be sine 45, right? All square. Then divide by what? 2 times 10 is 20, right? So we are looking for what? U square. Now sine 45 is still the same thing as 0.7071, right? So let's look for the square of 0.7071. 0.7071 times 0.7071. So we have 0.49. 0.49, which is 0.4999. So let me just take it as 0.49. Okay, let me take it as 0.49. Okay, so the square of 0.7071 give us 0.49, right? So we're looking for what? U square. So let you cross multiply to now be what? 2.4 times what? 20 is equals to what? 0.49 u square, right? So making you stand alone to be what? 2.4 times what? 20 divided by what? 0.49, right? So let's do it. Okay, before I just continue, we'll take the square of both sides, right? The square root of both sides. This one cancel this. So let's take the square root of everything here. So let's do it. So the square root of 2.4 times 20, then divided by what? 0.49. Okay. So the velocity is 9.8. So our velocity is what? 9.8. Okay. So we have gotten our velocity to what? 9.8. All right. So velocity is 9.8. That is velocity of projection. Now worry about the time taken to reach the greatest height. That is time of flight, right? Time taken to reach the greatest height. So t is equals to what? T equals to u over g. Okay. Yes, t equals to u over g. Since they involve angle. Remember, I gave you guys in the previous video, I gave you guys formula for time of flight. Two formula. One that involve angle, the other that does not involve angle. The other that does not involve angle is the one that involve angle is what? T is equals to what? U sine theta, right? Over what? G. Right? So yes. So since it's involve an angle, we are going to use this. Our velocity is what? 9.8, right? So okay, let me clean here. Velocity is 9.8. Okay, so let's use this formula now to look for time of flight. So I've already gotten our velocity to be 9.8. So time of flight will now be what? Remember, this is not total time of flight too. If it's total time of flight, we'll put 2 in front of this u. They say time of flight, okay? Yes. They say time taken to reach the greatest height. Time taken to reach the greatest height is different from total time of flight. Okay? So please, time taken to reach the greatest height is different from total time of flight. So let's continue. So t equals to what? U sine theta over g. So now be t is equals to our u is what? 9.8. Then sine 45. Sine 45 is what? Sine 45 is okay. Let me just put here sine 45. Then divide by what? G is 10, right? So it equals to what? 9.8 times. So sine 45 is 0.7071. Then divide by 10. So let's do it. So 9.8 times 0.7071 divided by 10. So when we do it, we get our time to be what? Time to be 0.69. Okay? 0.69. So the time is 0.69, the velocity is 9.8. Then the resultant distance, which is range. How are we going to look for range? Okay? Since now they are telling us to calculate for the range, right? The resultant distance. Okay, now range is what? Remember this question, the angle is at 45 degree. And remember, range is what? Range is maximum at 45 degree. Now what is the formula of range when range is maximum? Formula of range when range is maximum is equals to what? R equals to u square over what? G, right? So range is maximum when the angle is 45 degree. You did it just now. So u square over g. So our velocity is what? 9.8, right? All square divided by what? 10. So let's do it. So the square of square of 9.8 divided by 10 will give us 9.6. 9.60. So the range is what? Range is 9.604 meter. Okay. Time is 0.69 seconds. Velocity is 9.8 meter per second. So we are done with this part. Now let's move to this part. Question 5, which is the last part now. Okay. Oh my god, it's not easy. Alright, so let's solve this part now. Okay, which is the last part. If a particle is projected with a speed 30 meters per second at an angle of inverse tan 2, find the greatest height and the corresponding resultant distance. Find also the time of flight. So they're asking us to look for a maximum height and what? The time of flight. Now I want to tell you guys something regarding this time of flight. Let me not confuse you guys. Now there's what we call total time of flight. There's what we call time of flight. Now time of flight is the time it takes a body to reach maximum height, right? Yes. Why total time of flight is the time it takes a body to reach the maximum height and also fall to the ground, right? Yes. Now, in this question, now, if you say, okay, find also the time of flight. We are okay. Remember, time of flight. The formula for time of flight is t equals to u over g, right? Or t equals to u sine theta over g. That is when it involves an angle. Formula for total time of flight will now be t equals to 2u over g, or what? T equals to 2u sine theta over what? Over g, right? Yes. Now, normally, they say look for time of flight. You have to use this equation, right, to solve. Yes, you have to use any of this one to solve. But if you use any of this one to solve, you will not get your answer. But if you use this one to solve, you get your answer. I don't know if you understand. So what am I trying to tell you guys that is, for example, now let's say they say look for time of flight, because normally we all know that time of flight is this one. Total time of flight is not this. But if you solve in the question, the answer, if you solve using this in the question, you not get the answer. But if you use this one to solve, you get the answer. So what am I trying to tell you guys that in exam condition, let's say you solve, you didn't see, we solve using this, you didn't see your answer in the option. You can try this or down method, this or down one. Even though they tell you to look at time of flight, of which we know that time of flight is this one, total time of flight is this one. I don't know if you understand. So in exam condition, let's say they say look for time of flight, you solve using this formula, you didn't get your answer. Just solve using this one, okay? Yes. But if they ask you to calculate for the time to reach the greatest height, is this one, time of flight? Yes, is this one. We all know that time of flight is the time it takes to reach maximum height, right? Yes. What's the time of flight? Is the time it takes to reach maximum height and also to fall to the ground. So just be careful. All right. Now let's continue. If a particle is projected, let me clean this part. Okay, so if a particle is projected with a speed 30 meters per second at an angle of inverse tan 2, find the greatest height. So I telling us look for what? The maximum height, right? Maximum height. Then which of that we are looking for? We're also looking for what? The time of flight. So in this one, we are using total time of flight, right? Okay, so we are looking for a total time of flight. Okay. So now here problem comes in is this angle here. So now let me decipher this part. Okay, the rest part is easy. They gave us our velocity to be what? To be 30. All right. So we all know G is always 10. We have to use this formula for maximum height. U square sine what? Square theta over what? 2G, right? While for time of flight, 2U sine theta over what? Over G, right? So yes. Now, but the angle in which they give, the angle is what? Is inverse tan 2. So we have to convert everything to, we have to convert this to what? To sine theta. I don't know if you understand. We have to convert this one to sine theta. How are we going to do it? Let's start now. Now, inverse tan 2, they say the angle is what? They say theta is equals to what? Inverse tan 2, right? Inverse tan 2, right? Now, inverse tan 2, see something as what? See something as tan theta equals to 2, right? Yes, now, yes. Yes, because if you want to make the angle which is theta stand alone, you will take the inverse of tan. I don't know if you understand. So when you take the inverse of tan, you get something like this, shift tan 2. I don't know if you understand. So you get this one back. So this, so let's take everything back. Now be tan theta equals to 2. It's still the same thing with this. I don't know if you understand. Let's say you make this one stand alone. So now you now get this. I don't know if you understand. So since we want to get theta, we want to get sine theta. I don't know if you understand. So I can use it to solve. So this one now we take it back to this. I don't know if you understand. So now be tan theta is equals to 2. Now what next? Remember Pythagoras theorem now. Remember that one? Those two. I mean trigonometry. Those SOHCAHTOA, right? SOHCAHTOA. Now, so is sine theta equals to what? Opposite, right? Over hypotenuse, right? Then TOA is what? TOA is tan theta, right? Is equals to what? Opposite over what? Over adjacent, right? Okay. Yes. Now, what interests me here is this one. Okay. Now let's continue. Okay. So I can clean this part now. Yeah. Okay. I can clean this part. All right. All right. Okay. So the part that interests me here is this part here. Okay. So tan theta is equals to opposite of adjacent, right? Now, but if you look at it here, tan theta is equals to 2. I don't know if you understand. Tan theta is equals to 2. Tan theta, we all know that tan theta is equals to opposite of adjacent. Abi, in the question, they gave us that the angle is inverse tan 2. So when we take everything back, we now get this tan theta is equals to 2, right? Yes, but we know that according to trigonometry that tan theta is equals to opposite of our adjacent. Now, if tan theta is equals to 2, that tells us that opposite tan theta, opposite will be 2, then adjacent will be what? Will be 1. I don't know if you understand. If these two divide each other, we get what? 2 divided 1, we get 2. I don't know if you understand. So that's to tell you that opposite is what? 2. Adjacent is what? Is 1. I don't know if you understand because we know that tan theta is equals to what? Opposite over what? Adjacent, right? Okay, so let's continue. Now let's move to this part. Since we now know that opposite is 2, adjacent is 2. Now let's go. Since remember what did I tell you guys first? I told you guys that we have to convert from want to make tan theta. Want to convert from that tan theta to what? To sin theta. I don't know if you understand. So we want to convert from this part to sin theta, right? Yes. But we all know that sin theta is what? According to trigonometry, sin theta is equals to what? Opposite over what? Over hypotenuse, right? Yes. We know that sin theta is equals to opposite over hypotenuse, right? From the information given in the question, we know that we now know that tan theta is equals to opposite of adjacent. We know that the opposite is 2, the adjacent is 1. That is why when we divide 2 divide 1, we get what? We got 2, right? So we now know the opposite is 2, adjacent is 1, right? Now let's move back to this part. Sin theta is equals to opposite over what? Over hypotenuse, right? Yes. Now, according to Pythagoras theory, this question is kind of long, shall I? But let me just continue. According to Pythagoras theory is what? Is hypotenuse square is equals to what? Opposite square plus what? Adjacent square, right? Yes, this is Pythagoras theory, right? Now, if we want to look for hypotenuse, we already know our opposite, we have know our adjacent, but we don't know what? We don't know our hypotenuse. So we have to use Pythagoras theory to get our hypotenuse. I don't know if you understand. Once we get our hypotenuse, we know the opposite is 2, then we get our hypotenuse. Baba, it's a very long process. Let's do it little by little, okay? So let's continue. The opposite is what? Opposite is 2, right? So 2 square then plus adjacent is what? 1 square. We are looking for hypotenuse, right? Hypotenuse. So square, right? So if we make hypotenuse stand alone, we take square root of both sides. Hypotenuse now be equals to what? Root. The square of 2 is 4. Square of 1 is the square of 1 is still 1, right? So we now be left with 4 plus 1 will give us 5, right? So our hypotenuse is what? Is root 5. I don't know if you understand. So hypotenuse is what? Is root 5, okay? So let's go back now to this part. All right. So our opposite is what? 2. Our hypotenuse is what? Is root 5, right? So we have gotten sin theta to be what? Sin theta will now be equals to what? 2 over what? Root 5, okay? So that is just it, okay? But we are not done with the question. We have successfully gotten what? Sin theta, okay? Now let me recapitulate what I have said earlier. Now, in the question, they gave us theta to be what? They gave us the angle, or what am I even saying? Yeah, theta. They gave us the angle, which is theta, to be in what? To be in inverse tan 2. Now, if you convert this inverse tan 2 back, if you take it back, we have what? Tan theta is equals to 2, right? Yes, because normally tan theta now equals to 2, for example. Now, if you want to make this theta stand alone, we take the inverse tan, right? Yes. So if you want to take this one, we can also take this one back. I don't understand. So that is just it, okay? So this one is the same thing as this. You understand when we make theta to stand alone, okay? So we arrive with what? Inverse tan 2, okay? So we take it back to what? Tan theta. So tan theta is equals to 2, right? Now let's continue. So what I said earlier that okay, tan theta is equals to 2. Now if tan theta is equals to 2, we all know that normally, according to Soka tan theta is equals to what? Opposite of adjacent, right? Yes. So if tan theta is equals to 2, that means that opposite is 2, then adjacent is 1. 2 divided 1 will still give us what? Still give us 2. I need to understand. So opposite is 2, adjacent is 1. So from this information, we find out that opposite is 2, then adjacent is what? Adjacent is 1. I don't know if you understand. Okay, opposite is equals to 2, adjacent is equals to 1, because when if they divide each other, we will arrive as 2. I don't know if you understand. 2 going to 1, 2 divide 1, get 2. I don't understand. So that's to tell you that, oh, the opposite is 2, then the adjacent is what? 1, because why? That is equals to opposite of adjacent. Now let's continue. We have gone to this formation, right? Now, according to trigonometry, we also know that so which sin theta is equals to, we know that sin theta is equals to what? Opposite of hypotenuse, right? Yes. Now what are we now in this question? Normally in projectile we are using sine to solve, right? But in the question that they gave us in tan theta. So all these things we are doing, we want to convert from tan theta to what? To sin theta before we can solve. I don't know if you understand, because we cannot just solve using tan. So when we converted from tan to, we want to convert from tan to what? To sin theta. Now sin theta is equals to opposite of adjacent, opposite. Sin theta is equals to opposite of our hypotenuse, right? Yes, but we know that opposite is 2. We didn't know, but we know that opposite is 2, adjacent is 1. We didn't know what is hypotenuse. So we use Pythagoras theory, right? Hypotenuse square equals to opposite square then plus adjacent square. So 2 square plus 1 square, take the square root. So we find out that hypotenuse was root 5, right? So everything after look for everything, sin theta is equals to what? 2 root 5. Okay. So we have gotten our sin theta. We have converted from tan theta equals to 2 to what? To sin theta. Our sin theta is equals to what? 2 divided root 5. Okay. Oh my God, it's not easy. So sin theta is equals to 2 over root 5. Now, since we are not that our we know that sin theta now is equals to 2 over root 5, we have to impute this value. And to impute this value wherever we look for, wherever we see what? Sin theta. Okay. What are we looking for, by the way? We're looking for the maximum height. I'm also looking for the total time of flight. Okay. So let's continue. All right. So A should not be equals to what? Our U is what? 30, right? 30 square. Then sin theta is what? 2 and 2 divide root 5, right? So now be bracket open. 2 divide root 5. In the place of sin theta, we'll put what? 2 divide root 5, right? So do 2 divide root 5 all square. Divide by what? 2 times what? G is 10, right? So let's do everything. Once we do everything, we get our maximum height. All right. So 30 square. I'm coming now. Wait. All right. Let me start again. Okay. Bracket open, 30 square. Bracket close. Under bracket open again. Then 2 divide root 5. Okay. Bracket close, all squared. Then divide by 20. So when we divide by 20, our maximum height is 36. Okay. So our maximum height is 36. All right. So maximum height is 36 meter. Then what about our time of flight? Remember, sin theta is equal to 2 over root 5. Whenever we see sin theta, we'll put what? 2 over root 5. So t will now be equal to what? 2 times what? 30. Whenever you see sin theta, we'll put what? 2 root 5, right? Then divide by what? 10. So let's do it. So now be 2 times 30, then times what? Times 2. Divide root 5, then divide by what? 10. So when we do everything, we get the time to be the total time of flight to be 5.366 seconds. Okay, so this is it. Okay, so this is all you need to know about projectile, and this is all I've tried. So this is all the calculation you need to know. You need to know under projectile. Okay, so it's not easy. It's not easy at all. So especially this part, just go through it again. You can slow the video down and understand it for yourself. Okay, so it's not easy. Help support my ministry by subscribing, sharing, and all, because it's not easy at all. I'm sweating. All right, so now our next class will be our next class video will be our next topic will be um, force and eating laws of motion. That one also has a lot of calculations. Okay, so it's not easy. See you next in our next class.